Okay. We did our presentation on arithmetic and geometric sequences.
So here's some vocabulary that will be useful. So what is a sequence? It's an ordered list of numbers. So example 1, 2, 3, 4, 5, and it can be infinite or it can be, have a start and finish. And then a series.
A series is the sum of the terms of a sequence. So as you can see, the sum of 1, 2, 3, 4, 5 is 15. So that would be a series.
So the first sequence that we studied was the arithmetic sequence. And this is a sequence which has a definite pattern, meaning the terms are not random. And each term is the previous term plus a certain constant called the common difference added to it. So if you started with 2 and your common difference was 3, you go 2, 5, 8, 11, etc.
So here are the equations for arithmetic sequences. So this is the one that's used to find the next term in a sequence, which is L. And so F is the first term, and then A is the common difference, which, as we said before, is the constant number that you're adding to each term in the sequence. And then N is the number of the term that you want to find. And then the equation to find the series of an arithmetic sequence is S equals N times F plus L over 2.
Yeah. And this is the sum when you have a stated start and end. You can't really sum an infinite series or arithmetic series. So here, if we're going to sum this one, which is 1, 3, 5, 7, 9, 11, we realize that the common difference between each of these terms is 2. And the first number is 1, and n is the number of terms, which is 6. And the last number is 11. So we plug it into this equation to find the sum. So we get 6 times 12 divided by 2, and we get 36. And if you're going to do this in your head or on a calculator, you'd also get 36. Yeah, you can use a calculator.
This is just a little example problem. So the arithmetic sequence goes as follows: 3, 7, 11, 15. So what's the common difference? 4. Nice job. So if you were trying to find the 101 term of the sequence, of the series, so you find the common difference, which is 4. Then you would plug in F, which is the first number, which is 3. Then A, which is the common difference of 4. And then N, which is the number of the term we were searching for, which is 101. And you plug that all into the equation, and then you solve it to get 403. So you know that 101st term is 403.
Yeah. And you'll often see problems like this in math. It doesn't necessarily have to be a stated problem like this, but problems will involve arithmetic series as their answers or sequences. So it's actually really useful to know these equations. Okay, this is a real life example. There are 10 aliens in a room.
Real
They're
life.
all very friendly. So they shake hands with everyone they meet, but never with the same person again because it's against their laws. So the first person, if there's 10, can shake hands with 9 people, right? But the second person, they've already shaken hands with the first person, so they can shake hands with 8 people, right? All the way down to the last person, second to last person, who could shake hands with 1 person. So this is an arithmetic sequence, so 9, 8, 7, with a difference of -1, right? So the first term is 9, we know that. The last is 1, and so there are 9 terms total. So we plug that into the equation for the sum, and we find out that 45 handshakes occurred in this alien community, which is very useful.
Especially if you're with a group of aliens.
Yeah. Now we're going to move on to geometric.
Okay, so geometric sequences are also sequences with a definite pattern, which again means that they're not just random numbers. And each successive term is multiplied by a constant term, like which is different than arithmetic because in arithmetic you add a term. And so the fixed amount that it's multiplied by is called the common ratio, or R. And it can be defined as a to the k power, where k goes from 0 to n.
I mean, k can start anywhere. You should start at 0 though, and this is how you can define it. And a would be the common difference.
You said common difference, you mean common ratio.
Common ratio, sorry. Yeah, common difference is for arithmetic. Okay, so these are the two formulas. There's actually a couple, and we were going to show you a video of how you can get the sum, but I don't think we have enough time for that, so we're just going to give you the formula. So this is one of them to find any term of the equation, a sub n. And this is the term to find the sum, but there is another equation that I think is a to the n plus 1 minus 1 over a minus 1. It's something like that, but you'll see why that's relevant in a second. So here's just an example. You can see the common ratio is 3, multiply each term by 3. And we can sum it because it has an end and a beginning. Time. Okay, we have lost. So this is another example. But here, if we have 0.5 to the k. Now since 0.5, if you look at this equation, 0.5 would be a, right? And the higher the power you raise it to, and since this is an infinite series, and yeah, it'll get smaller and smaller and smaller. So we can disregard it because really it will be 0. So instead we're left with negative 1 over a minus 1, which is really just a divided by 1 minus a. And so then you can actually sum an infinite series, infinite geometric series, if the common ratio is less than 1, which is how we can do 1 half that series. And this one will equal to 2, which is also proving Zeno's paradox, why you will eventually get there mathematically.
Okay, 30 seconds.
Okay, so this is a cool problem, but I guess we'll just explain it to you instead of showing it. You can click on the link actually. So there are two trains, and they're traveling at 10 miles per hour, and they're 20 miles apart, and they're heading towards each other. And there's a fly that starts on one of the trains traveling at 15 miles per hour, and so it keeps zigzagging back and forth till finally it's smushed. So you want to find out what's the distance that fly covers, and if you do the math, you'll realize that it's an infinite geometric series. So there's a famous mathematician, von Neumann, and he was asked this question, and he calculated all in his head in a matter of seconds that the answer was 15 to this infinite series, which would otherwise have taken a long time to write down. But he did it so quickly. But the trick is to this problem. So they're 20 miles apart, right? And they're traveling at 10 miles per hour. So they'll take an hour before they crash. And the fly is traveling at 15 miles per hour, so 15 is the answer. But so they asked him, oh, you know the trick? And he said, what trick? I just solved an infinite geometric series. Great.
Okay. Can we stop there, Rose? Is that good?
Yeah, I think this is the last slide.
All right. 3 minutes for questions. 3 minutes for questions. Okay, questions?
Ben?
Would you mind going back to the slide where you had a couple of the equations for arithmetic sequences, because I wasn't able to copy down all of that?
Here are
Arithmetic, I believe it was.
arithmetic sequences. I wrote them on the board.
Oh, there you go. And what is like F and A equal to in
F
those?
is the first term, L
Okay.
is the last term, N is the number of terms, S is the sum. L here
That
is
makes
the term
sense.
you're trying to find. F is
Okay.
the first, A is the common difference, and N is the number of the term you want to find.
A is
This is for
So,
finding a certain term. This is for
The sum of the series is actually the average of the first and the last terms times the number of terms. That's
Yes.
what that is.
Yeah,
F
it's
plus L divided by 2.
yeah, it's the same thing when we learned about 1 plus 2 plus 3 plus 4. It's the same reason that works. Because if you take 1, 3, 5, 7, 9, when you add these together, this will be 10. Oh, yeah, this will be 10 too. And so then you multiply by
You divide it by 2
yeah,
to get the average.
Yeah, because when you divided 2 of the series together, it's twice as many as you need. So then you divide by 2. So it's the same reason that works.
Any other questions? Okay, now, before we move on, I just wanna say that what I'd like everybody to do, what we decided in the other class would be a good idea, is to post either your, is this a presentation?
It's a Google
This is a
Doc.
Google Doc, right? If we can post all the presentations on our email server, then everybody who wants to can take a look at them, you know. Yeah, I mean, I don't really want you to sit here and write down things, I want you to pay attention and learn things, but if you need to refer to this again, it would be great if we could all post that stuff. Is that something we can do?